Hello, and welcome to our presentation of the Ruben's tube experiment. I am William Price, and this is my partner Marcus McLean. In this experiment, we will be demonstrating three scientific concepts.
The first concept is that sound is the oscillation of pressure in the form of a wave.
The second concept is that as the volumes increase, the amplitude of a sound wave will increase.
Finally, as we increase the frequency of a sound, the wavelength should decrease, and we can see this in the Ruben's tube. Let's check it out.
First, we'd like to go over some safety precautions we took throughout the course of the experiment. First, as you can see, my garage door is open. This is so that any gas can escape through to the atmosphere. Secondly, you can see there's a hose ready if there's any issues. Finally, as you can see, we're using a standard size tank. We did not start with a tank this big. We tested it with a smaller tank first for obvious safety reasons and worked our way up. And also, like all tanks, it has a one-way valve, so there's no chance of the flame escaping back into the tank. Marcus will now discuss the various parts of the Ruben's tube.
What we have here is a 36-inch long aluminum tube. Along the course of the entire tube are perforations at each half-inch interval. At each end, we have a diaphragm made of latex covered by saran wrap. At this end, we have a 3-inch speaker connected to a sound source. Here's our fuel source, which is propane, with a one-way valve connected to a tube which splits into two other tubes marked at the 25% and 75% locations on the Ruben's tube. All of this is mounted on a 2x4. Now, when I apply, actually, first let's light it. As you can see, there is a uniform row of flames.
I'm going to kill the lights so we get a better visual of the flames.
The reason all of the flames are uniform is because there is no sound being passed through the tube. However, when I apply some sound, we can see that there will be a sine curve in the formation of the wave. This is 400 hertz.
You can clearly see three separate crests of the curve. One here, and one here. The troughs in between them. Now, if we go up to 700 hertz, it moves up to 4 crests. 1, 2, 3, 4. This is because basic physics, as the frequency goes up, the wavelength will get shorter. Now, if Marcus increases the volume, the amplitudes increase. Decreases the volume, the amplitudes decrease. Once again, back to 400 hertz. We only have 3 crests, and the volume concept can be shown at 400 hertz as well. And back down. Now, if we kill the sound, we get a straight line again. Now, we're going to put some music to it. Guns N' Roses, Welcome to the Jungle. And as you can see, I'm not touching the gas valve. All the fluctuation of the flames is either Marcus alternating the volume or the different notes change the flames on their own. Marcus will sit at one constant volume. The flames fluctuate according to the line of the music.
As I decrease the volume, we can see that the flames also decrease in size. And the opposite happens when I increase the volume. And that is our Ruben's Tube project.
Thank you for watching.